The Sun, a 4.5 billion-year-old yellow dwarf star, is a hot, glowing ball of hydrogen and helium at the center of our solar system. Located about 93 million miles, 150 million kilometers, from Earth, it is the only star in our solar system. The Sun's energy is essential for life on Earth. From Earth, the Sun appears as a constant source of light and heat, but it is a dynamic star, continuously changing and emitting energy into space. The study of the Sun and its effects on the solar system is known as heliophysics. The Sun is the largest object in our solar system, with a diameter of about 865,000 miles, 1.4 million kilometers. Its gravity keeps the solar system together, maintaining the orbits of all the planets and debris. Despite its significance to us, the Sun is an average-sized star. Some stars are up to 100 times larger, and many solar systems have more than one star. By studying the Sun, scientists gain insights into the functioning of distant stars. The hottest part of the Sun is its core, where temperatures reach 27 million degrees Fahrenheit, 15 million degrees Celsius. The surface, or photosphere, is cooler at about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Interestingly, the Sun's outer atmosphere, the corona, gets hotter as it extends outward, reaching up to 3.5 million degrees Fahrenheit, 2 million degrees Celsius. The Sun has been called many names. Sol is the Latin word for the Sun, leading to the term solar. In Greek mythology, Helios is the sun god, inspiring terms like heliosphere and helioseismology. While the Sun's extreme temperatures and radiation make it inhospitable, its light and energy are crucial for life on Earth. The Sun, a medium-sized star, has a radius of about 435,000 miles, 700,000 kilometers. It is far more massive than Earth, with a mass equivalent to 330,000 Earths and a volume that could fit 1.3 million Earths. The Sun is about 93 million miles, 150 million kilometers, from Earth. Its closest stellar neighbor is the Alpha Centauri system, with Proxima Centauri at 4.24 light-years away and Alpha Centauri A and B at 4.37 light-years away. Located in the Milky Way's Orion Spur, the Sun orbits the galaxy's center, taking about 230 million years for one complete orbit. The solar system moves at an average speed of 450,000 miles per hour, 720,000 kilometers per hour. The Sun rotates on its axis, which is tilted at 7.25 degrees relative to the plane of the planet's orbits. Its equatorial rotation period is about 25 Earth days, while the poles rotate once every 36 Earth days. Although the Sun has no moons, it is orbited by planets and their moons. Early in its history, the Sun was surrounded by a gas and dust disk, some of which remains in the form of dust rings tracing planetary orbits. The Sun formed about 4.6 billion years ago from a collapsing gas and dust cloud, the solar nebula. The Sun contains 99.8% of the solar system's mass, with the remaining material forming planets and other objects. Excess gas and dust were expelled by the young Sun's solar wind. The Sun will eventually deplete its energy, expanding into a red giant that could engulf Mercury, Venus, and possibly Earth. It will ultimately shrink into a white dwarf, with an estimated remaining lifespan of about 5 billion years. The Sun is a massive ball of hydrogen and helium held together by gravity. Its structure includes the core, radiative zone, and convection zone. The visible surface, the photosphere, is followed by the chromosphere, transition zone, and the corona. The corona's material becomes the solar wind, creating the heliosphere, a magnetic bubble extending beyond planetary orbits. Beyond the heliosphere lies interstellar space. Nuclear reactions in the core, where hydrogen fuses into helium, power the Sun's energy. This energy radiates outward, taking about 170,000 years to reach the convection zone, where temperatures drop below 3.5 million degrees Fahrenheit, 2 million degrees Celsius. The sun lacks a solid surface. The photosphere, emitting visible light, serves as its surface. This layer is about 250 miles thick and has temperatures around 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Most of the sun's radiation escapes from the photosphere into space. Above the photosphere are the chromosphere, transition zone, and corona, forming the sun's atmosphere. Features like sunspots, coronal holes, and solar flares are seen here. During solar eclipses, the chromosphere appears as a red rim, and the corona forms a white crown with plasma streamers. The corona's higher temperature compared to the lower layers is a major mystery in solar studies. The sun's magnetic fields create the interplanetary magnetic field, carried by the solar wind, forming the heliosphere. This rotating field creates the Parker spiral. The sun undergoes cycles of activity, known as the solar cycle, with magnetic pole reversals approximately every 11 years. Solar maximum, the peak of activity, features sunspots, solar flares, and coronal mass ejections. Solar cycle 25 began in December 2019, with the next peak expected in July 2025. Solar activity affects Earth, causing space weather that can disrupt satellites, GPS, and power grids. The strongest recorded geomagnetic storm, the Carrington event of 1859, caused widespread telegraph malfunctions and brilliant auroras. Similar events in 1989 and 2005 disrupted power and communication systems. Quick sun facts asterisk. Length of day: 25 Earth days at the equator, 36 Earth days at the poles. Length of year: the sun orbits the Milky Way's center every 230 million Earth years. Star type: G2V, yellow dwarf main sequence star. Surface temperature: 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Corona temperature: up to 3.5 million degrees Fahrenheit, 2 million degrees Celsius. Before we explore the planets, let's first understand what a planet is. The term planet originally referred to wanderers, seen as moving lights in the sky. With recent discoveries, we now have a more precise definition based on scientific information. The International Astronomical Union, IU, has classified planets and other bodies in our solar system into 3 categories. 1. A planet is a celestial body that A. Orbits the sun, B. Has enough mass for its self-gravity to overcome rigid body forces, resulting in a nearly round shape, hydrostatic equilibrium. C. Has cleared the neighborhood around its orbit. 2. A dwarf planet is a celestial body that A. Orbits the sun, B. Has enough mass for its self-gravity to overcome rigid body forces, resulting in a nearly round shape. C. Has not cleared the neighborhood around its orbit. D. Is not a satellite. 3. All other objects, except satellites, orbiting the sun are collectively known as small solar system bodies. Now, let's return to our main topic, the planets of our solar system.